Good afternoon, everyone. I have the pleasure of having one of the very last slots, and I'm hoping to keep you awake with something a little bit different. So you've been hearing mostly about autism today and yesterday, and I'm going to be speaking to you about a genetic disorder called Tuberous sclerosis complex. Now, one of the things that make tuberous sclerosis, or TSC, quite interesting is that it's the genetic disorder most commonly associated with autism spectrum disorder. So people with TSC, up to 50% of them will also actually have an autism spectrum disorder. I'm going to share with you a study we've just recently completed, and the topic is multivariate data analysis identifies natural clusters of TSC-associated neuropsychiatric disorders. So first, I'm going to tell you a little bit about TSC, and then we're also going to look specifically at the neuropsychiatric phenotype of TSC. I'm going to share with you some of the challenges we've had in the past and some of the challenges we're facing at the moment, and then I'll share with you the results from a large-scale study, and as I said, we've just completed that, so this is actually the first forum that we're sharing the results in. So tuberous sclerosis, or TSC, is a genetic disorder that gets caused by a mutation in either the TSC1 or the TSC2 gene. If you look here, the TSC1, TSC2 protein complex acts as an upstream regulator for the mammalian target of rapamycin. So if there's disruption in this pathway, this leads to overactivation of mTOR, which then leads to dysregulated cell growth and proliferation. TSC has a birth incidence of 1 in 6,000, and it has an equal male-female distribution. 75% of cases are sporadic mutations, and then the remaining 25% are inherited in an autosomal dominant manner. Now, TSC is a multi-system disorder, and what that means is that basically any organ system can be affected by TSC. And I'm going to show you a few examples. About 90 to 95% of people with TSC will have some central nervous system manifestations, as you can see here. And they're different. They're cortical tubers, we're looking at radial lines, and then this big one you're seeing here is called a SAACAPAP. Also, up to 90% of people will have dermatological features. You can see facial angiofibromas, that's a shagreen patch. Here we've got fibrous plaques, and then it also affects the nails and the nail beds. Kidney disease is also a real concern in TSC. And then cardiovascular features are also found, and this is, interestingly enough, mostly found in infants and toddlers. And then it also affects the pulmonary system, and this actually also affects mostly women. What is interesting about this is that these features emerge over time. So some of them are more prevalent in infancy and childhood, such as the cardiac rhabdomyomas, and then the other ones actually emerge into adulthood, which is mostly where we see diseases with the kidney. Then looking at the neuropsychiatric phenotype, when you actually speak to families and individuals with TSC, despite all these physical manifestations, they will tell you that their number one concern is actually the neuropsychiatric manifestations. It's extremely variable, and no two individuals seem to present with the same neuropsychological problems and difficulties. What also adds difficulty here is that there are multiple dimensions of TSC-associated neuropsychiatric disorders, or TAND. If you look at our image here at a behavioral level, individuals report difficulties with aggressive outbursts, anxiety, depressed mood, self-injury, repetitive behaviors. At a psychiatric level, as I mentioned, up to 50% of people will also have an autism spectrum disorder. There's also very high rates of ADHD. And then we're also seeing anxiety disorders and depressive disorders. The intellectual ability ranges from superior ability to profound disability and impairment. In terms of the academic level, we see difficulties with reading, writing, spelling, mathematics. And at the neuropsychological level, there are lots of issues with attentional skills and executive functioning, working memory, planning, those kind of things. And then obviously we also have the psychosocial level that's affected. What is most important to note here, though, is that the majority of individuals with TSC will have some neuropsychiatric manifestations, with a lifetime prevalence rate in the region of 90%. In terms of our previous challenges, the biggest one that we've had to face is what we call an assessment gap. So a study conducted in the United Kingdom found that only 18% of individuals were actually being screened for these neuropsychiatric manifestations, which means there's about an assessment gap of 70%. What we wanted to do to address this assessment gap was to raise awareness, and one of the steps to do that was to coin the term TAND, TSC-associated neuropsychiatric disorders. As a next step, we wanted to help clinicians in the systematic review and identification of these neuropsychiatric manifestations, and to do that, a specific TAND checklist was developed. The TAND checklist is a pen and paper tool. It's very easy to complete in 15 minutes. It's simple, yes or no questions. And the best part is that it's free of charge. So I'm sure most of you know that most assessment tools and screening tools are very expensive, so it was very important for us to keep it free of charge. In 2013, we validated the TAND checklist, and it showed very good internal validity. We compared it with some well-validated, internationally used tools such as the Strengths and Difficulties questionnaire, the Social Communication questionnaire, and the brief. And it also showed that this simple tool was able to also extract some of this data and be able to identify individuals that are at risk for these manifestations. So currently, the challenge we're facing is what is termed overwhelming uniqueness of these TAND profiles. So now we've got individuals, and they are now actually being assessed for these manifestations, but what it appears is that people have very unique profiles, and this makes it very difficult for psychoeducation and intervention planning. So when we did the pilot validation of the TAND checklist, we collected data from 20 individuals in South Africa. So the columns represent the 20 participants. And here we've got 19 behavioral items. So these were some of the things we mentioned earlier: anxiety, temper tantrums, aggressive outbursts. And the red blocks indicated where a parent would say that, yes, my child has suffered with this in the past. And the green is no, there's never been an issue with this. So by just looking at this, you can see that no one seems to have the same profile. It seems to be pretty much all over the place. However, if you look at the second graph, what we did here is we just started moving some of the participants around and some of the items, and now what we can see is there seems to be a group that's affected across all levels. And we seem to have a group that's not really affected. And then in the middle here, you can see that some of these variables start to group together. So based on this, we've set out to then conduct a pilot study to see if we can actually identify natural TAND clusters. So the objectives of this pilot study was firstly to investigate the practicability of identifying natural TAND clusters. Secondly, we wanted to identify the suitable multivariate data analysis techniques, which we could then apply to a larger scale study. And then we also wanted to explore the optimal number of cluster solutions. It's no use we coming up with 17 or 18 clusters. We were really looking for something below 10. We collected TAND checklist data from 56 individuals in South Africa and Australia, and as I mentioned, they filled out the TAND checklist. And then we applied multiple techniques. So we looked at various cluster analysis techniques, we looked at exploratory factor analysis techniques, and essentially what the pilot said to us is that we were able to generate natural groupings or natural TAND clusters from this data. So this was very encouraging, and then after that we set out to do a multi-center, much larger scale study, and that's what I'll share with you now. The objective of this study was to confirm and expand the findings from our pilot study, and our methods were pretty similar to the pilot study, which is why we did the pilot study, but I'm going to take you through the process. TAND checklist data was collected from 453 individuals across 6 sites internationally. And then we computed mean square contingency coefficients. And as with the pilot study, we then looked at both cluster analysis as well as factor analysis. In terms of the cluster analysis, we looked at various methods. So we looked at hierarchical methods, we looked at partitioning around medoids and fussy clustering. And based on all of this, we then chose the best cluster analysis method. What we also wanted to add with the larger scale study was to look at the robustness of these clusters, and therefore we also applied bootstrapping. Then another addition in the larger scale study was to look at the internal consistency of these clusters. And then again, we went to our exploratory factor analysis, and there we applied different factor extraction methods, different rotation methods, and again we looked at the different number of factors, so a 4-factor solution, 6, 7, or 8. And within this, we also did internal consistency, and then as a final step, we compared our cluster analysis results with those of factor analysis. And here are the results. So for factor analysis, the same as with our pilot study, we also found that again, it was Ward's method that gave us the most clinically meaningful clusters. And here, 7 clusters were identified. The next step then was for us to apply the bootstrapping to assess the statistical robustness or the stability of the clustering solution by calculating the number of times each pair of variables cluster together. So a value of 1, as you can see in these dark areas, basically means that all of the variables within this cluster cluster together 100% of the time. And the fact that we have quite a lot of dark blocks here means that it's just by eyeballing it, it's quite robust. Next, we looked at factor analysis. And here, 7 common factors were identified, and I'm going to briefly take you through them. The first one was a scholastic factor. Then we had a mood and anxiety factor, an ASD-like factor, behavioral dysregulation, neuropsychological, overactive impulsive, and then the last one we called eat and sleep, and this referred more to the biological functionings. There were some overlap with 2 or 3 items in terms of self-injury, disorientation, and sleep. You can see that they cross-load on more than one factor. So the next step was to compare our cluster analysis with our factor analysis. So the dotted lines refer to the clusters that were rendered with Ward's method, and the solid lines refer to our factor analysis. So if we just start off in the bottom corner here, this is our scholastic factor, and you can see that this was exactly the same for both cluster analysis and factor analysis, and the same with our overactive impulsive. On the top here, we have our neuropsychological cluster, and you can see visuospatial skills is the only variable the cluster analysis actually included as well. At the bottom here, we have our mood, anxiety, a little bit of overlap with inflexibility and sleep. And here we've got our aggressive outbursts, temper tantrums, but it's in the middle bit that it gets pretty messy. So we weren't quite sure what to do there. So we actually went back to all of the data collected. We looked at the cluster analysis, we looked at the factor analysis, and then we looked at the bootstrapping again to see which ones of these actual clusters have the most robust groupings of variables. And based on that, these are the 7 natural tan clusters that we propose. A neuropsychological cluster, some of you might be familiar with internal consistency. So the Cronbach alpha for this was 0.87. So anything above a 0.7 means it's got good internal consistency. So the items in the neuropsychological cluster are difficulties with dual tasking, executive function difficulties, attention-related difficulties, memory problems, disorientation, and visuospatial difficulties. The next cluster is a behavioral dysregulation, and these are individuals with difficulties with aggressive outbursts and temper tantrums. The ASD-like cluster, and you can see it's got a very high Cronbach alpha of 0.8, and here we've got unusual language, poor eye contact, again attention difficulties, language delay, inflexibility, repetitive behavior, peer difficulty, and self-injurious behavior. There's our eat and sleep cluster. We've got a mood and anxiety. So these are mood swings, depression, anxiety, and extreme shyness. Our scholastic cluster, you'll notice this has got the highest Cronbach of a 0.97. And then finally, our final cluster, overactive impulsive. So these are individuals with difficulties with overactivity, impulsivity, and restlessness. So in conclusion, the larger scale study findings were actually remarkably similar to those that we found in our pilot study. And this then in turn supports the robustness of our findings. This data-driven approach identified 7 natural tan clusters from within very highly variable tan checklist data. Thank you very much. I'd like to acknowledge the Tuberous Sclerosis Association in the UK, UCT for some of their seed funding, all of our international collaborators, all the families that took part, and finally Prof. de Vries and my lab team. Thank you very much.
We have some time for questions, so if there are any questions from the audience, now would be a good time to ask. Anybody have a question for Loren?
You're not allowed to ask questions, Prof.
Do we have a mic? Ah,
It's coming.
Petrus, apparently you need to stand.
Thank you, Loren. Of course, I'm going to say that was an excellent presentation, but you ended a bit abruptly. So, for people who are not experts in TSC, who may not be that familiar with it, tell them what's the kind of so what of the finding? You know, what's the point of having found these 7 things? What might this help us do next?
Well, I can't let the cat out of the bag.
No, that's fine. But what's your
Yes.
what will be useful next?
Yeah. So at the moment, the reason why this is so significant is, if you recall the beginning of the presentation, we spoke about the fact that it seems so overwhelming. So when individuals do go and see some of the TSC experts, what's happening is the nephrologist that's treating the kidneys knows nothing about neuropsychiatric disorders and TSC. And, you know, the same with the neurologist that looks at it. So what's been happening is there's also what we call treatment paralysis. So when a patient actually goes and sees their treating physician that handles their TSC, they don't know how to treat these neuropsychiatric manifestations. So with us being able to give them robust, natural clusters, they are easier now able, because this is a tool that they can use. So as I said, it's the first time we're sharing it with you guys, but this will be used at an international platform alongside with the TAN checklist. So now when a patient goes and they actually see their clinician, they can go through the TAN checklist, and then that's the so what. So the so what is, yes, so this child falls within these one or two clusters, and then based on that, we can then give them resources in terms of next steps and interventions and treatment options. So in the for now, this is the benefit, and then you'll have to wait until next year to see what we have in store. Thank you.